Hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back with one another renewable energy project, and which is MATLAB project. That is a solar wind grid integration with supercapacitor as a power buffer for battery. So yes, by going through the name, you can see there are five different sources: solar energy, wind energy, grid. Grid is our power supply, and battery with supercapacitor. Why we have used the supercapacitor, we will check each and everything in detail, but just giving you the brief overview that supercapacitor is used to supply a momentarily power. So high amount of power which is required for momentarily to save our battery life cycle, we have used a supercapacitor. So you can see high amount of power for a very short time period, the supercapacitor will be provided. So we will check how this simulation is working, what is the purpose of each and every component in detail in next few slides. So you can see here, this is the index which we will cover in the next section. So what is the problem definition? So I just wanted to tell you that I have already uploaded the video regarding to the energy sources, renewable energy sources. So you can see on my YouTube channel that there are numbers of video. This is the first video, which is basic video, in which I have integrated solar, wind and grid. Whereas in the second video, which is the solar, wind, grid and battery integration, which is also very helpful to you. And this project is now upgrade model of that two videos or that two models. So yes, each and every model has their unique benefits and unique consideration. So we are going through each and everything in this section by this PPT. Okay, so most electricity is generated from the non-renewable source. Non-renewable sources mean coal, natural gas, nuclear energy, and once this resources is used up, they cannot be replaced. Okay, so once it's used up, it's become empty. What is a major problem for humanity is we are currently depending on them mostly we are depending on the coal, natural gas. So in the future it will be used up. There is no availability of that type of fuel in the future. So why we are going to the this uh, major concern? Because the another problem is the pollution. Fossil fuel is a pollution because enormous amount of usage of non-renewable sources cause the pollution. Pollution is also a major concern, so we need to consider it also. So these two are some basic problem and which cover in all the renewable project. But the third one is something different and some technical consideration. So what it is? Due to rapid loading on battery. So when you sudden applied load on your battery, cause high current. Obviously, when sudden load is come to the battery, the high current will be taken by the load, and that current will be withstand by your battery. High current spike will be withstand by your battery and continuously on off loading. If your load is continuously on and off, this also cause high current spike. And what happened due to that, battery cause reduction in battery life cycle. So what is the life cycle? Charging and discharging, charging and discharging, charging and discharging. So there is a cycle, life cycle. So each and every batteries have some cycles. So you can see that normally we have considered a 3000 life cycle. So you can charge your battery 3000 and obviously discharge your battery. Okay, so one cycle. So we have considered 3000 usually as per research paper. So this battery life cycle reduced. Why reduced? Because due to the high current spike. High current spike caused the reduction in the battery life cycle. And to get rid of this scenario, we need some alternative resources which tackle the load for short time duration. So what that alternative source? That is supercapacitor. So that's why I have used supercapacitor as a power buffer for battery. That's why I have changed the name or set the name accordingly. Okay. So this is a very basic problem definition and which is very much related to our simulation. So this is the introduction, and I am suggesting that you need to go through the all the slides, because if you directly jump to the simulation, nothing will be matter. Because if you don't know the basic behind the simulation, what is the purpose, what is the logic, you don't know the logic, then you will not get any idea about this. Okay, simulation is very simple, but what is done in that is covered in these slides. Okay, so yes, you need to wait. We are switch over the simulation also. There is simulation at the end of the slide. Okay, So just I am giving again a brief overview. What is the logic, brief introduction of our project. Logic behind this project is to integrate the multiple sources with load and grid. Okay, so there is multiple sources. Obviously, there is a wind, there is a grid, there is a solar, there is a battery. So you can see solar, wind, grid, battery, supercapacitor are connected each other and supplying the electricity to your household load. Okay, so this is I have considered. You can see here in the basic block diagram, there are the different energy sources: wind, solar, battery, supercapacitor, grid, and your residential load. So normally, whenever the wind and solar energy is sufficiently available, most power is feeding to the residential load by these two components, wind or solar, or any of it. You can provide the power from wind alone also, or solar alone also, even battery alone also. So usually the logic is that mostly wind and solar will feed the power to the load, and if these both fail, then the grid will provide the power to our residential load. Okay, and similarly the battery will charge through grid also, and whenever, or in previous case, when the wind and solar both are sufficiently available, battery would be charged through these two components also. Okay, so battery can charge on the non-renewable energy or renewable energy. These are renewable energies, these are non-renewable. So you can consider that battery can charge on wind, battery can charge on solar, and battery can charge on grid also. Okay, so yes, and if grid is available sufficiently and wind in solar is not available, then grid can provide all the power to your residential load. Now what happens? Grid is also failed. So there is only a supercapacitor and battery come to. So very momentarily, very short time, very short amount of time, like a 0.2 second to 0.02 second. It depends on simulation timeline. So for that amount of time, the supercapacitor will come to the picture and tackle all the residential load. And after this time, battery come to the picture and smoothly tackle all. So how this is happening, we will check in the simulation. So this is a basic logic behind this. Okay, we are again get back to the introduction part. With the help of sun energy, solar, wind, intensity, electricity can be generated. Okay, with solar energy is generated from the solar radiation, wind energy is generated from the wind. Okay, but energy is not fixed, varies continuously depending on the weather condition and the wind. Obviously, you can get the solar energy in the daytime, but you cannot get the solar energy in the night time. Again, wind energy also depend on the weather condition and the wind speed. So these energies are not a continuous energy. So you need some alternate source to get a proper supply and the frequency at the load side. Hence here develop the logical controller which helps switch over the different sources for the availability. So you can see in the we have different sources. So if any one of the fail, the another is able to supply the load or feed the load. So now we are switch over to the scenario 2. So what is the scenario 2? Scenario 2 is that only solar power source. Solar power is available, supply to the total load. Meanwhile, wind grid is not available isolated. Battery is also charging on the solar. Okay. So you need to change the simulation according to requirement. Okay. Yes, I am opening the simulation. Stop the simulation. So right now what it says that, what scenario says that there is no wind speed. Okay, there is no wind speed, and but there is only a solar. I am clicking on the solar switch and start the simulation. Okay, I am starting the simulation. So you can see here initially my grid breaker is closed. Even though my solar is started, but it takes some time. There is some logic, 650 volt. Whenever the 650 voltage is generated, or more than 650 voltage is coming at this stage, then and then my solar breaker will close and it will feed to our total load. So yes, obviously, solar takes some time to generate a satisfaction. That's why we need to wait. Okay. So for a momentarily or for a small time, wind is a grid is available. And once the satisfactory voltage is generated, the solar come to picture and paid the total load. So at this stage the voltage is coming, which is a 400. Whenever it's cross 3650, this breaker will get on, and the solar is directly feeding all the power to the load, and this breaker will get off. This right now it is on condition. This is our power fail condition, but which is not right now in use. This is our grid breaker. Okay, you can see the voltage is coming 650, 650. Okay, slide variation. That's why this slide variation is that because sudden load causing some variation. So once the satisfactory power is there, okay, you can see again it's come to the stability condition, and right now it is a stable. This is one. This is off condition. This breaker is on condition. Yes, you are getting proper output. So yes, initially it was from the grid, and then why this variation is there, because right now the inverter come to the picture, and inverter has some ripple. You cannot get a clear sine wave. There is some ripple because we have used the inverter. So yes, this is how your uh, solar is supplying total load, feeding power to the total load, and wind is isolated, and battery is also charging. Supercapacitor is also charging, and this scenario similar to the previous. Okay, so yes, so this is how the simulation is working. Different condition of the radiation according to the situation. So we have considered the daytime because we want to generate a power from the solar. So you can switch off the power from the solar here also by just switch over the night time. Okay, so whenever I switch off this daytime and switch on the night time, my voltage will be reduced and again go back to the grid. Okay, so yes, it is totally automatically. If solar power is sufficiently available, then solar will feed total load through it, through on the total power load will get the power from the solar. But if solar is insufficient to generate some voltage proper, then the grid, the solar will be isolated and come back to grid. Okay, automatically. Here right now, as I change this switch, as I change the night time, directly this breaker gets off and this breaker gets on. Total power is feeding by the grid. This is how the simulation is working for the second scenario. Again, you can see here the grid, then solar, then again grid. Okay, I'm switching off the simulation part, and we are go to the third scenario. So it's the second scenario. You can see here in the daytime, and wind is not right now. Wind is not there. That's why we have to switch off all the switches. You can see wind is not isolated. That's why I have switched off all the switches. Now we are going to with the third scenario, that is the wind power. So the third scenario is also similar to the solar, but here we have used the wind. So wind power is available and supply total load. Meanwhile, solar and grid is isolated or not available. Battery and supercapacitor will be charged over it. Okay. So battery and supercapacitor can charge on solar also, wind also, and grid also. Okay. So just go back to the simulation part and check how the simulation is working, or how you can run scenario. So there is no solar. Okay, night time, no solar, and right now I need to switch on these two switches, which help to change the input speed of our wind turbine, and it will generate some satisfactory voltage. Once this voltage satisfactory come at the output side, the total load. So initially our grid breaker is on, and all the power, the load is getting power from the grid. And yes, it's obviously wind turbine. The turbine takes some time to achieve the speed and to achieve some satisfactory voltage. Okay, take some time to generate a voltage, and you can see here the voltage generation at this stage. I already uploaded the video, uploaded the screenshots, the PPT. This is how the wind come to the stable condition. The PID tuning graph. I have used the PID controller to get a proper output voltage, and this by this logic. Okay. So right now wind is starting and the power is getting from the grid, and there is some satisfactory voltage and the power is also there. The one light is reducing because as battery gets charged, load reduce. So sometimes it's come to the stable condition. So yes, we need to check here. So voltage is coming to the rated value, but yet breaker is not closed. It's the final breaker. In this stage, we need to just wait, check how the simulation is working. Okay, so finally our breaker is closed and you can see here the voltage variation. Voltage is coming to the stable condition. After some time, voltage comes to stable condition. And if you wanted to check how the so right now wind is supplying power, so there is no grid. So grid breaker is in the off condition, but right now it is on. Why it is on? Because our breaker is yet not started. Yet not started. Why it is yet not started? Because previously it was started, but it takes some time to PID tuning takes some time to come to the stable voltage. So one peak and one down, and after some time. So once it's come to the stable condition, then we will get a proper out. So we need to wait at this moment. So after waiting some times, you can see here that this breaker is on by display, and yes, voltage is coming to the stable level, and yes, you can see how the voltage is stable, and yes, the output is you can check here. The output breaker is also on. Wind is totally and the grid is totally off. Wind is totally in the stable condition. Wind breaker is isolated, and total power is fed through the okay, and you can see here the waveform. There is some spikes over there, and after some stable waveforms are coming. The three part, this is the wind part. So this is how the scenario 3 is completed. You can see here the grid to wind transition. Then we can transit from solar to wind and to solar by similar situation, whereas initially daytime and wind is normal. So solar and wind both are together and jointly fed the power. This is our scenario 4. So initially the grid is there, and after some time, whenever wind is come, initially a grid is there, then after some time solar is there, and after some time whenever wind started, at that time solar and wind both are together and supply the total load. Okay. Scenario 5, solar to wind or wind to solar. So initially both solar and wind power our load. Solar was healthy in the daytime and normal wind speed. After some time, solar to wind changeover. Solar is a daytime and there is no wind. So you can see initially both are fading to the power, but after some time, whenever wind speed is not sufficient to generate power, so wind turbine is isolated and only solar is there to feed in the load. So you can see how smoothly transition from the solar wind to only solar. Similar situation can be arise from the wind to solar. Initial from the solar to wind. This is from the wind to solar. So again, initially solar and wind both are available, both are feeding the power, and after some time, or you can see that in the night time, solar is not available, so only wind is there and wind is supplied. You can create the scenario by using this logic. I think you can do it right now in the simulation. So what is the sixth scenario? Sixth scenario is important. Sixth scenario is there. Initially solar is there. Initially wind is there. When there is no solar, there is no wind. At this condition, it should be transferred back to the grid. So yes, obviously if grid is available, then it go back to the grid. You can say initially come from the inverters and then from the grid. So I am creating this situation in the simulation. So initially I can start the daytime, okay, and the okay, wind is also available. Winds take some time. So I am just start simulation, and yes, I have started the simulation, but initial condition, solar and wind both take some time to generate a satisfactory voltage. Exactly, power is fading from the grid. After some time, when solar and wind both are getting satisfactory voltage, grid breaker is isolated. So we need to wait in this moment. Wind is also solar is also generating the power, or you can see voltage. You can see the voltage here also. Both are starting. So just get back to the scenario 647 in the this fact. So as we know that renewable energy sources are not continuously feeding the power, as wind speed may varies as per atmospherical condition. Similar problem. Similarly, problem with the solar power is not available during the night cloudy weather. During night time also solar is not sufficiently generate the voltage, and during the cloudy weather, if the weathers are cloudy, no satisfactory sunlight is available, and then voltage will be reduced. Okay. Hence duration this time reliable power sources. Hence during this time reliable power source, that is only a grid itself. So right now the simulation is in the running condition and wind is there and the grid is isolated. Okay. And whether solar is there, wind is there or not. Solar is there, but need to check wind is there or not. Yet not. Winds take some time to generate a satisfactory voltage. Once winds also generated, we will isolate it one by one different sources, wind and solar, and check whether it get back to the grid or not. Obviously, it will get back. So this is the auto logic entity developed by this logical controller logic gate. Very simple. There is no nothing. So just I am isolating the grid, the wind. Okay. I am isolating the wind, and as I isolated the grid solar, you can see here it will get back to the grid. This is a 0, this is a 1 by this. Sorry, the night time is off. Breaker is okay. So you can see here waveform. You can see here initially it was from the grid, then solar, and then again get back to the grid. Take some time to come to the stable situation. So this type of waveform will be created. Sixth scenario, solar wind to grid. Okay. So right now this seventh scenario is very much important. What is the seventh scenario? No power source available. No power source condition. So right now supercapacitor will come to the picture and battery will come to the picture. So you can see before scenario, before what happened, daytime, normal wind speed and grid availability. But when I change night time, there is no solar, there is no wind. By changing no wind speed, when grid power fail, and grid power is also fail. At this condition, during this condition, supercapacitor and battery come to the picture simultaneously. Initially, supercapacitor come to picture, take all the load and reduce high current spike on battery. Later, battery come to picture and feeding the entire load. So this is written in the scenario also. No power source available. 7 scenario. Grid power available and supply to the total load. Meanwhile, solar and wind is isolated. Battery as well as supercapacitor can be charged over it. So what is mentioned here? Grid power available and solar and wind is not there. So grid is available. That's why battery and supercapacitor can be charged on the grid. Now if grid power is fail, whereas solar and wind is not available, at this condition only battery is there with the supercapacitor. So here initially fraction of time supercapacitor come to the picture, take out the load and then immediately the total load transfer to the battery, and the battery as well as supercapacitor both are discharging. Okay. So right now we are again going back to the part and check whether how the waveforms are look like. Okay. So this is supercapacitor part and this is supercapacitor. So you can see initially the power spikes that is come on the supercapacitor, which is a 200 ampere, which is a normal ampere is 40 to 50 ampere, whereas spike is a 200 ampere, which is nearly 4 times. And yes, you can see initially the capacitor was charging, and then when it comes to the picture, it got start the discharge. The voltage This is the capacitor value, and this is the current high current spikes. You can see spike type waveform. So if this waveform or if this load is directly come to the battery life may reduce to the, you can see, to the 300 3000 cycle charging and discharging cycle to the normal lifespan of battery is 3000. If expert calculation, you will get a nearly 280. So your life reduce 80% if you don't use capacitor. Okay, and at load side also there is a 600-volt spike directly on the, if this direct spike on the battery may reduce the battery life. So that's why this spike covered by the supercapacitor. And you can see here no power, so there is no spikes on battery and transition on battery from the supercapacitor. You can see very clear current. This is a charge and this is the voltage. So there is no spike in the current and your battery life is improved. Okay, so you can see no spike at the load side from supercapacitor to grid. So initially it was from the supercapacitor and then from the battery. Okay, this is at the load side. It's a very clear waveform. So right now we need to establish the logic in the simulation. Okay, so yes, obviously this is the one. So grid is available. There is no wind. There is no solar. There is no solar night time, and there should be a no wind. I can switch off these two switches. Okay, so no wind. Only grid is there, and I am right now I am failing the grid power by this switch, power fail switch. As I switch on, the breaker is off, so my grid power is fail. My supercapacitor breaker is on, battery breaker is off. You can see here supercapacitor breaker is on. This one is on, and total power is paid by the supercapacitor. Now, if you want to check the spike that are coming, you can see here. You can see how the battery is discharging. Okay, and yet battery is not come to the picture. You can see this is a spike, current spike that we have developed here. This time directly come to the supercapacitor. This is how you can save your battery life. After some time, supercapacitor breaker will get off and battery will get on and totally load feed by the battery. Okay, you can see supercapacitor breaker off, battery breaker on. The supercapacitor is totally isolated. Right? Yes, you can see sudden discharge, and then it comes to the stable condition because it is isolated. So you are thinking about that why we are getting very spike in the current. Actually, it is a major spike if you compare to the current value, the 200. Okay, nearly 100 to 200. And the battery, you can see how clear battery is come to the picture. There is no spike in the current. You can see here very smooth transition. There is no spike, nothing, just a simple 50 amp. You can see very similar, very clear. And at the output side also, whenever the power fail, okay. So initially a high spike withstand by the supercapacitor, this one, and then the battery. So this scenario is covered in the simulation part. Initial spike covered by the supercapacitor and then come to the battery. and this is stable. No spike at the battery to supercapacitor. Supercapacitor to battery, not a battery to supercapacitor. No spike at the load side. Smooth transition on battery from supercapacitor. So there is no spike whenever it transfer from the supercapacitor to battery. The spike is occur whenever the supercapacitor is come to picture, because we want that all the spikes, all the unnecessary current spike, voltage spike must be withstood by the supercapacitor, and only a smooth transition is happen to the battery. So this is a smooth transition. There is no spike. So this is from the my side. This is the reference, and thank you for watching this video. If you have any queries, just comment it. I will definitely reply. You will get PPT report, research paper, simulation files in the description box. You can connect with me through my email ID that is given in the description box. For any type of MATLAB project, for any type of electronic project, you can connect with me through my email ID that is in the description box. Thanks for watching this video. Don't forget to like and subscribe my channel Infinite Knowledge. Thank you again.